Hi everyone, welcome to InterviewPro. Let's solve another LeetCode problem today. This is a medium level question and it was asked in a number of interviews. So this is the question to find all duplicates in an array. We will be given an integer array nums which is of length n and all the integers are in the range 1 to n. Each integer can appear once or twice. Return an array full of integers that appear twice. You must write an algorithm that runs n big O of n time and uses only constant extra space. Let's not consider these two conditions as of now. Let's just focus on how to solve this question. If we start with brute force, we'll take the first element, then loop through the entire array and see if there is any duplicate or not. If there is any, we'll add it to our result array. Otherwise, we'll move to the next element, then loop through entire array again and find the duplicate, then add it to this array. Since 3 is a duplicate, we add it to the result array. Same with all other elements. So 2 is another duplicate element. Our final result array will contain 3, 2. For each and every element, we loop through all items in the array. The time complexity will be big O of n square, which is not as per the given condition. Let's move to the next approach. The other approach is to sort this array. What would be the result? 1, 2, 2, 3, 3, 4, 7, 8. Now, once the array is sorted, we start with the first element and check if the next element is same as the first or not. If yes, we add it to our result array. Same goes with the second element. We check if the next element is the same or not. Then we add it to the result array. If it's already present, we'll skip it. Then we'll move to the next one. We keep adding it to the result array whenever it's a duplicate. This will take big O of n log n time because we are sorting the array, which takes big O of n log n time. This is also not as per the given condition. The third approach can be using a dictionary. We'll take a dictionary here that will contain key value pairs. We'll loop through each and every item in the array. First, it's 4, it occurred once. 3, it occurred once so far. 2, 1, 7, 1, 8, 1. 2 is already present, will increment the occurrence. 3 is also present, will increment. Then 1, which occurs one time. Then we'll go through this dictionary and see which element has more than one frequency. These are the two elements, 3 and 2. So this is going to be our result set. Here the time complexity is big O of n because we are looping through the array only once. The constant space condition is not satisfied because we used a dictionary which takes big O of n space in the worst case. We somehow achieved this big O of n time complexity. Let's see how to achieve the constant space. Let's look at the given statement properly. The statement says all the integers are in the range 1 to n. That means it doesn't contain negative integers. All are positive. This is the first point. Second, the integers range from 1 to n. For example, if we take this array, the minimum element is 1 and the maximum element is 8. So the advantage of the numbers ranging from 1 to n is that the index will start from 0 to n minus 1. So every element has its corresponding index here. If we take this number 4, do we have the index 4 minus 1, 3? Yes, we do. And what is the element here? 2. And if we take this element 8, do we have the index 8 minus 1, 7? Yes, we do, which has the element 1. So every element has an index. At that index, we have an element. So if we can find an approach to make sure that the element is visited, we can come up with a solution. Let's see how to do that. Let me clear this first. I'll create the array here. 4, 3, 2, 7, 8, 2, 3, and 1. Indices are 0, 1, 2, 3, 4, 5, 6, and 7. Let's start from the value 4. This is at index 0, the element is 4. We'll calculate the index for this element 4 minus 1, which is 3. We'll go to the index 3, it has an element 7. We have to mark this as visited. So how do we do that? We can multiply it with minus 1 and make it a negative integer. When we come across a negative integer, we know that that element or that index is already visited, because in array there are no negative integers, correct? So we marked this as visited. Now we'll increment the pointer to the next index. This has an element 3. 3 minus 1 is 2. At index we have the element 2 and we'll make it negative. Then we'll move the pointer. This is already negative. So every time we take the element in the array, we take only the absolute value. So the absolute value is 2 minus 1 is 1. So we'll go to the index 1 and mark this element as visited. We'll increment the pointer. The element here is 7, taking the absolute value. This gives us the index 6. Going to index 6, we have an element 3. So marked it as visited. Increment the pointer. We have 8. 8 minus 1 is 7. We go to index 7 and mark the element as visited. Increment the pointer again. We have element 2. 2 minus 1 is 1. Go to index 1. This element is already negative. That means it is already visited. If another element index is also pointing to the same element which is already visited, that means the current element pointed by this pointer is the duplicate. So let's add it to our result set. I'll put our result set here, add it to. We'll increment the pointer, taking the absolute value 3 minus 1 equals 2, going to index 2. This is already negative. That means this is already visited by another element, which must be a duplicate, right? So 3 is also a duplicate, adding it to the array. Incrementing the pointer, taking the absolute value and calculating index, we go to index 0. This is not visited yet, so make it negative. Now we reached the end of the array, so we'll stop calculating and this is our final result set. Let's recap what we did. We went to each and every element in the array. For every element, we calculated an index by subtracting minus 1. We went to that index and marked the element pointed by that index as negative, so that if there is another element in the array with same value, basically a duplicate, it would also give us the same index which we have already visited. If there is an element which is negative, that means that index is already visited by the same value previously, telling us that the current element is the duplicate. And whenever we come across such elements, we add it to our array. So this is how we calculate the duplicates. In this approach, as we are looping through each and every element in the array, the algorithm will take big of n time complexity. We are not making use of any extra space, so we are using only constant extra space because we are making use of the given input array. Let's see how the code looks like. This is the question and I'm coding in C#. I have already given the code here. I've taken a list. This is going to hold our result of duplicate elements. Then we loop through each and every element in the array. We'll calculate the index by subtracting minus 1 to the current element. The element at this index, if it is less than 0, then we know that this was already visited by some other element. That means the current element is a duplicate. We'll add it to our list. Otherwise, we'll simply multiply it with minus 1, marking it as visited. Finally, we'll return our list. Using this technique, we achieved the given time complexity and the space complexity. There is one catch here. We are modifying the given input array, which is not ideal. So always make sure with the interviewer if he or she is fine with modifying the input array. If you want to make sure that the input is back to normal after our processing, loop through each element of the array and okay, let me write the code here. For I equals 0, I less than nums dot length I plus plus. If the element nums of I is less than 0, just multiply it with -1 so that it becomes positive, which is nothing but original array. If I run this, all test cases are passed. If I submit it, all test cases are passed. So this is how you find all duplicates in an array. I hope the solution is clear. If you like the content, please like, share and subscribe to InterviewPro. Thank you.